welcome again. Now, after completing the fourth unit, which was related to statics, now this is time to switch over to dynamics part of engineering mechanics. Now, our fifth unit is related to dynamics. Uh, Fifth unit, it basically deals with rectilinear motion. Under this, we will be discussing about rectilinear motion of a particle moving with non-uniform acceleration and uniform acceleration. Under uniform acceleration, we will be discussing about motion under gravity, and after that we shall discuss about relative motion and other minor topics of dynamics. So let us begin with our fifth unit, kinematics of rectilinear motion. Now, to start with the actual contents of the subject, let us define the term rectilinear motion. So what is rectilinear motion? When particle is moving along a straight line, then its motion is called as rectilinear motion. Now, to study this topic, we must know few important terms which are directly associated with rectilinear motion of a particle. So let us start with position. Position of a particle. So what is position? Normally in engineering mechanics or in any mathematical subject, geometry, we are defining position of a point. Suppose a point is in the first quadrant, we can define its position with respect to coordinates x and y. So we can write position P into bracket x comma y bracket complete. So in this way we can define position of a particle. Here the particle under consideration is moving along a straight line. So when a particle is moving along a straight line, it occupies a certain position with reference to a fixed point, and normally such fixed points are referred as the origin, denoted by O. Now in this figure, this is origin, and the particle is moving along x-axis. Particle is moving along x-axis. So this is x-axis and particle is moving along x-axis. So this is the position of particle for the instant shown in figure, and this position can be defined with respect to x ordinate, and y will be equal to 0. So px 0. Here in this second figure, this is origin, and now particle is moving along negative x direction. So position can be defined like this, p minus x 0. So this is about position of a particle. Then next important term is displacement and distance traveled. So purposely here these two terms are written opposite to each other so that one can clearly differentiate between these two terms. So what is displacement? Displacement is the shortest distance between the initial position of a particle and its final position during its motion. So displacement is a vector quantity. To define a vector completely, we have to mention its magnitude as well as direction. So displacement is a vector quantity. Now in this figure, particle is moving from point A to point B, and particle is following a curved path from A to B. So this is the path now followed by the particle. So A is the initial position of the particle, while B is the final position of the particle, and the shortest distance between initial and final position of particle is called as displacement. So this is displacement of particle. Okay, and it is a vector quantity. While defining this quantity, we have to mention its magnitude as well as its direction. Now let us consider the second figure. In this figure, the particle is moving along a semicircular path. So again, point A is the initial position of particle and B is the final position of particle. So here in this figure, particle is starting its motion from A and it follows a semicircular path and it reaches to B. So here in this case, the horizontal displacement is the shortest distance between the initial position, that is A, and final position, that is B. So this shortest distance is called as displacement. So here this is displacement, shortest distance between the initial and the final position of particle. Now what about distance traveled? So distance traveled is the total path covered by a particle during the given time interval. So it is actually length of the path traveled by the particle. It is a scalar quantity. So to define distance traveled by a particle, we did not have to mention its magnitude, but only, sorry, we did not have to mention its direction. Only magnitude will serve the purpose. So we can define this quantity completely by its magnitude only. Direction is not at all required, while in case of a vector we have to mention its magnitude as well as direction. Now let us consider this figure. So here the particle is starting its motion from point O and it moves along a straight line and reaches to new position 40. Okay, and here the particle stops for a while and reverses its direction of motion, and again it starts moving towards the origin and reaches to position 20. Now the distance traveled by the particle is total path covered by that particle. So here particle is starting its motion from O, it travels to 40 and again it reverses its direction of motion and reaches to 20. So total distance traveled by the particle is 40 plus this distance 20. So total distance traveled is equal to 60. While the displacement, it is the shortest distance between the initial and the final position of particle. So this is initial position of the particle, it travels to 40, it comes to 20. So this is the final position of the particle. Here purposely these two paths are shown separately to avoid the confusion. So here this is the final position of the particle, and the shortest distance between these two positions is displacement. So displacement is equal to plus 20. Here suppose if we consider this figure, particle is traveling from A to B via this path. Okay, so the shortest distance between the initial and final position is displacement, while the distance traveled is length of this path traveled by the particle. This is distance traveled. Now in the second figure, particle is starting its motion from O and it reaches to 40, 0 to 40. At 40 the particle stops for a while and reverses its direction of motion, and again it starts moving towards the origin. Particle crosses the origin and moves to the left of origin, and now this is new position of particle minus 10. So the distance traveled is equal to plus 40, again 40, 80, plus 10, 90. So total distance traveled by the particle is 40 plus 40 plus 10, 90, while its displacement is minus 10 to the left of origin. So in this way we can differentiate between displacement and distance traveled by the particle. Now velocity. Velocity is one more important quantity in dynamics. Velocity can be defined as rate of change of displacement, and it is a vector quantity. So to define velocity completely, we have to mention its magnitude and direction. It has magnitude and direction. Its unit is meter per second. We are using SI system, so its unit is meter per second. And mathematically it can be expressed like this: V is equal to dx by dt, where dx is change in displacement and dt is the time interval in which this change is taking place. So velocity is a vector quantity which needs magnitude as well as direction, while speed is nothing but distance traveled by a particle in a particular time interval. Speed is a scalar quantity having magnitude only. So to define speed completely, we have to mention its magnitude only. We did not have to mention its direction. In case of velocity, both magnitude and directions are required. Third quantity is acceleration. Rate of change of velocity is called as acceleration, and it is a vector quantity. Its SI unit is meter per second square. So these are the three important quantities related to our study. Now we will switch over to the actual contents of the syllabus, that is rectilinear motion with variable acceleration. So when an acceleration can be called as a variable acceleration. So when acceleration, given acceleration is function of either displacement, that is x, or velocity or time, then it is called as variable acceleration. For example, here in this equation, acceleration is given as a is equal to 2t cube plus t square plus 5t plus 3. So here acceleration varies with time, so it is function of time t, and hence it is called as variable acceleration. Okay, so you will come across problems like this when acceleration is function of displacement, that is x, acceleration is function of time t, or acceleration is function of velocity v. So these are the cases related to rectilinear motion with variable acceleration. So let us discuss first case when acceleration is function of time t. So a is equal to f of t, and suppose now we are having a problem like this. Acceleration of a particle is defined as a is equal to t cube plus t square plus 5t plus 3, and now our problem is find velocity and displacement when t is equal to 3 seconds. So this is our problem. To find velocity at time t, we have to convert this equation in terms of v and t. Similarly, to calculate x at time t, we have to convert this equation in terms of x and t. Then only we can solve this problem. So how to convert given equation as per our requirement, that we will discuss. So given is a is equal to f of t. So this acceleration, it can be expressed as dv by dt. So dv by dt is equal to f of t, means acceleration is function of time t. Now we need equation in terms of v and t. So rearranging the equation, dv is equal to f of t into dt. So if we integrate this equation, we will be having equation in terms of velocity and time, v as function of time t, and thus for any value of time t, velocity can be obtained. Now our second problem is find x when time t is given. So now we have to convert the given equation in terms of x and t. So already we are having an equation in terms of velocity and time t. So v is equal to f of t. So if we integrate this equation, integration of dv is equal to integration of f of t, and here integration of dv is equal to v is equal to f of t. Now integrating this equation, after rearranging it, dx is equal to f of t into dt. Integration dx is equal to integration of f of t into dt. So after integrating this equation, the result will be equation in terms of x and t. So using this equation, we can find value of x for time t. So in this way the problem can be solved. So simple integration, or sometimes we will have to take derivative to solve such problems. Okay, so in this way the problem can be solved. Now the second case is when acceleration is function of displacement, a is function of x. Now let us assume one equation, a is equal to x cube plus 3x square plus x plus 2, and our problem is find velocity at x is equal to 3 and find x when time t is given. T is equal to 2 seconds. Okay, so to calculate velocity at given value of x, we have to convert the given equation in terms of v and x, while the given equation is in terms of a and x. So we have to convert it into in terms of v and x as well as in terms of x and t, then only we can solve this problem. So given equation is function of x, a is function of x, but we know a is equal to dv by dt is equal to f of x, and our requirement is equation in terms of v and x. So using chain rule, here I am using chain rule, dv by dx into dx by dt is equal to f of x, and here dx by dt is equal to velocity, and hence dv by dx into v is equal to f of x. Now rearranging the equation, v dv is equal to f of x into dx, and if you integrate this equation, it gives us equation in terms of v and x, which is our requirement, and thus v can be obtained for any value of x. So here you can write x is equal to 3 and you can calculate velocity. Also, as v is function of x, it can be expressed as dx by dt is equal to f of x, because we know velocity v is equal to dx by dt. Now rearranging the equation again, dx upon f of x is equal to dt, and if you integrate this equation, the result will be equation in terms of x and time t, and thus you can calculate x for a given time t. Okay, now let us switch over to numericals based on this topic. So I will read the statement of the problem. Velocity of a particle in rectilinear motion is given as v is equal to t square minus 5.3 t plus 5.7 meter per second. Determine acceleration of the particle when particle reverses its direction of motion. So here very important thing is the given condition. Find acceleration when particle reverses its direction of motion. And as discussed earlier, when particle reverses its direction of motion, it stops for a moment and its velocity reduces to 0. And then after that, the particle can reverse its direction of motion. So here the given condition is find acceleration when particle reverses its direction of motion, means when v is equal to 0. So this condition is given. This condition is very important. Without knowing this condition, we cannot solve the problem. So when such condition is given, it means that you have to use that condition to solve the problem. There is no other option. So let us discuss the solution. Given v is equal to t square minus 5.3 t plus 5.7. Since we need acceleration when particle reverses its direction of motion, and we know when particle reverses its direction of motion, it stops for a moment and hence its velocity is equal to 0. So here we will write v is equal to 0 in this equation, and solving the algebraic equation, quadratic equation, we can calculate t. T is equal to here 3 seconds and t is equal to 1.5 seconds. So when t is equal to 3 seconds, v is equal to 0, t is equal to 1.5 seconds, v is equal to 0. And v is equal to 0 means particle is reversing its direction of motion. So here the particle reverses its direction of motion twice. At first instant t is equal to 1.5 seconds and second instant t is equal to 3 seconds. So these two values of time t we can use to calculate acceleration. Therefore let us develop equation in terms of a and t, that is acceleration and time t. So simply taking derivative of given equation a is equal to dv by dt, we can write a in terms of t, 2t minus 5.3, and thus at t is equal to 3 seconds, a is equal to 2.3 meter per second, and t is equal to 1.5 second, a is equal to minus 2.3 meter per second square. This must be 3, not 3.8. So t is equal to 3.8. This is the acceleration. When t is equal to 1.5, this is the acceleration. Here acceleration is having negative sign, but the answer is correct. Negative acceleration is called as retardation. Now this is second problem. I am reading the statement. Position of a particle which moves along a straight line is defined by x is equal to t cube minus 6t square minus 15t plus 40, where x is in meters and t is in second. So determine time at which velocity is equal to 0. So we will discuss one by one. First, it is good practice to write given data like this. Given equation x is equal to t cube minus 6t square minus 15t plus 40, and we have to calculate time t when velocity is equal to 0. Find acceleration at the above time and find distance traveled by the particle from t is equal to 4 seconds to t is equal to 6 seconds. Okay. So here first part we will consider time at which v is equal to 0. Here we must have equation in terms of v and t, velocity and time t. So given equation is in terms of x and t. Okay. So v is equal to dx by dt. So v is equal to 3t square minus 12t minus 15. if v is equal to 0, if v is equal to 0, then 3t square minus 12t minus 15 is equal to 0. So solving above equation, t is equal to 5 seconds and t is equal to minus 1 second. So here, ignoring the negative answer, when v is equal to 0, t is equal to 5 seconds. So first part is over. Now part B. So this is part B. Find acceleration at above time. Find acceleration at above time, A. Find acceleration at above time. So here acceleration is equal to dv by dt. So A is equal to 6t minus 12. So t is equal to 5 seconds. Acceleration is equal to 18 meter per second square. So in this way we can find acceleration of the particle for the above time. And C, position or distance traveled. Position or distance traveled by the position and distance traveled at that time. So here find position and distance traveled by the particle at t is equal to 0. At t is equal to 0. So to calculate distance traveled, initial position of particle must be known. So when you need distance traveled, you must know the initial position of the particle. So initial position means when t is equal to 0. So we know that x is equal to t cube minus 6t square minus 15t plus 40. So put t is equal to 0, it gives us initial position of the particle. X0 is equal to 40. This is initial position of the particle. And now calculate position at t is equal to 5 seconds. So at t is equal to 5 seconds, that is x5, let us write t is equal to 5 seconds in the given equation of x, and it gives us x5, that is minus 60 meter. Remember, we have to calculate distance traveled from t is equal to 4 seconds to t is equal to say 5 seconds. Here it should be 5 seconds, not 6. Please make this correction. This is 5 seconds. Okay. So initial position of the particle is known. X0 is equal to 40. We need distance traveled by the particle when t is equal to 5 seconds. So put t is equal to 5 in given equation of x and calculate x5. X5 is equal to minus 60. So what is the distance traveled by the particle? Now particle starts its motion from x0. X0 is equal to 40 meters, and at t is equal to 5 seconds it reaches to minus 60. So it crosses the origin here. Here it crosses the origin. So it starts its motion from x0 40 meters and it moves to the left. It crosses the origin and it reaches to minus 60. And hence the distance traveled by the particle from when t is equal to 5 seconds is 40 plus 60 is equal to 100 meters. So this is the distance traveled by the particle at the above time, means when velocity reduces to 0. So time at which velocity is equal to 0. At this time we have calculated acceleration and the distance traveled by the particle from t is equal to 4 seconds to t is equal to 5 seconds. This must be 5 seconds. Okay. So here this part C is distance traveled from t is equal to 4 seconds to t is equal to 5 seconds. And for this distance traveled is equal to 100 meters. Then this is third problem. The velocity of a particle is given by v is equal to 20t square minus 100t plus 50, where v is in meter per second and t is in second. Determine the velocity of particle when a is equal to 0. So given data, v is equal to 20t square minus 100t plus 50, v is required, a is equal to 0. To find velocity at a is equal to 0. Now given equation is velocity as a function of time t. So a is equal to dv by dt. We know how to calculate acceleration, dv by dt. So taking first derivative, a is equal to 40t minus 100. Now when a is equal to 0, t is equal to 25 seconds. easily you can solve this equation. And now find velocity at this time t. Then write t is equal to 25 seconds in the given equation, and you can calculate velocity at the given time interval. And this is next problem. A particle travels in a straight line with accelerated motion of a is equal to minus kx, where x is the distance from starting point. Find constant k. If x is equal to 2 meters, velocity is 4 meters. When x is equal to 3.5 seconds, velocity is 10 meters per second. Also find x when v is equal to 0. So given a is equal to minus kx, find constant k for the given conditions when x is equal to 2 meters, v is equal to 4 meters per second, x is equal to 3.5 meters, v is equal to 10 meters per second. Remember, while dealing with such problems, first we have to calculate constant k. Without finding this constant k, we cannot solve the problem. So finding constant k is an important task while solving this problem. So first we have to calculate k. Okay. Now to calculate k, we can use these two conditions. Our given equation is in terms of a and x, while the conditions are given in terms of x and v. So remember, we have to modify this equation in terms of x and v to calculate k. So how to convert the given equation in terms of x and v? Let us discuss. Given a is equal to minus kx. So a can be written like this: dv by dt is equal to minus kx. Okay. Hence dv by dx into dx by dt, this is chain rule, is equal to minus kx, and hence it can be written like this: dv by dx into dx by dt is equal to minus kx dx by dt is equal to v, and hence the equation v into dv by dx is equal to minus kx. Okay, and rewriting the equation v into dv is equal to minus kx into dx. Now integrate this equation. If you integrate this equation, it will be in the form of v and x, but again one more unknown is introduced here, that is c. V square upon 2 is equal to minus k into x square upon 2 plus c. Okay, our main problem is find k, but to find k we have to use these two conditions in terms of x and v. Hence we are converting this equation in terms of x and v. So during this conversion, one more unknown is added in the problem. That unknown is c, and now we are having two unknowns, k and c, and we are having two conditions. So this problem can be solved. We have to develop two equations in terms of k and c, and these two equations can be developed using these two conditions. Okay, so this is the equation after integrating the term. Now there are two unknowns, k and c, and we are having two conditions: x is equal to 2 meters, v is equal to 4, x is equal to 3.5 meters, v is equal to 10. So using first condition, this is our equation A. After integrating, v square upon 2 is equal to minus kx square upon 2 plus c. Now in this equation, write v is equal to 4 and x is equal to 2, and thus we can develop first equation in terms of two unknowns: c minus 2k is equal to 8. Now let us use the second condition: x is equal to 3.5 and v is equal to 10, and develop second equation: c minus 6.125k is equal to 50. Solving these two equations, we can calculate values of c and k. So c is equal to minus 12.38 and k is equal to minus 10.194. Okay, hence equation A can be written as, now in this equation we will replace k and c by their values. 0.5 v square upon 2, 0.5 v square is equal to minus k is having minus sign, minus 10.194, minus plus 10.194 upon 2 into x square plus c is minus 12.38. So this is our equation. Now our equation is in terms of v and x, and we need x when v is equal to 0. So in this equation, write v is equal to 0 and calculate x. So x is equal to 1.558 meters. So in this way the given problem can be solved. Now after this, in the next section we shall discuss about motion with uniform acceleration. We will be using three equations: v is equal to u plus at, v square is equal to u square plus 2 times as, and s is equal to ut plus 1 half at square, along with motion under gravity. Now here uh, I would like to discuss one point in problem number 2. So here part C is distance travelled from t is equal to 4 seconds to t is equal to 6 seconds. So correct it as t is equal to 0 to t is equal to 5 seconds. T is equal to 0 to t is equal to 5 seconds. And to find distance travelled from t is equal to 0 second to 2 is equal to 5 seconds, here first we have to calculate position at t is equal to 0, then position at t is equal to 5, and thus we can calculate the distance travelled by the particle from t is equal to 0 to t is equal to 5. So this correction is required in this problem. Find distance travelled by the particle from t is equal to 0 to t is equal to 5 seconds. So this is all about non-uniform acceleration. These are the few important terms which you must know to solve the problems on non-uniform acceleration. So in the next section we will discuss about rectilinear motion with uniform acceleration with three well-known equations of motion along with motion under gravity. Thank you.